Hey everybody, in this video we're going to continue our study of section 2.2 and section 2.3 from our textbook. And so we're going to start with this example, finding the formula for the function shown. So notice that this is a piecewise function and it's comprised of three pieces. So we have this horizontal line, then we have a line that appears to have a slope, and then this other horizontal line. So we're trying to find the formula for the function. And so this is a piecewise function, so we're going to have three different rules because of the three different pieces. So one of the things that I usually like to start with anytime I have piecewise functions, whether I have the graph, like in this case, or in the previous video, we had the function, is to start with where the pieces get split. I call them the split points. So looking at my scale, this is each little square is a 1. Right? This is 1 and then it looks like 1, 2. So this split, right, this jump in the functions happens at -1. And the next one is these two functions, and that's 1, so this must be 2. So those are my split points. So that means I have the interval from, and this goes on forever. So it'll be the interval minus infinity to -1, or when x is less than -1. So in this case, because it's solid, when we write the first rule, this is going to be included. And now this line, the one with slope, it goes from -1 all the way to 2. So that's the interval -1 to 2. And looking at where the solid points and open circles are, this is open, so it's going to be a parentheses, and this one is close for the middle piece. So that will be a bracket, which means that then x is greater than -1 but less than or equal to 2. And then we have the last interval, which will be from 2 to infinity, or when x is greater than 2. Now this is open, so it's not included, so I don't put the equals there. So those are my three intervals. And we always read things from left to right. So I'm going to start writing my piece from -infinity to -1. So when x is less than or equal to -1, what do we look like? We look like this line. This is a horizontal line at 1. So that means this is the line y equals 1. So it's going to be 1 when x is, right? Remember, f of x is just a fancy name for y. So y equals 1 during that interval from -infinity to -1 when x is less or equal to -1. The middle piece, I have to do a little bit of work, so let's come back to that one. The third piece is from 2 to infinity, and this is again a horizontal line at, my scale is 1, so this is -1, and this must be -2. So this is the line y equals -2. So that means it's going to be -2 when x is greater than 2, because that is my interval. So now let's figure out the middle line, the middle piece. So that is a line, and I have 2 points on it, so I can find the slope. So let's look at this point. Even though it's not included, we can still use it to find the equation of the line. And if you're not comfortable using that, you can use 1, 1 and 1, 0, but I'm just going to use the endpoints. So I have, this is the point, so that's 2, so that's -1, 2, and this is the point 2, -1. So I want to find the equation of this line, right? So I can put it in my middle piece. So this is y equals mx plus b. So let's find the slope. So I'm going to go y equals mx plus b. So I need we need the slope and a point, right, to find the equation of a line. So the slope is the change in y over the change in x, or y2 minus y1 over x2 minus x1. So for our points, I'm going to start with the bottom point here. So -1 minus 2 over, and then the change in x. Since I start with -1, I have to start with 2. 2 minus the x value, -1, which is what do I get? Minus 1 minus 2 is negative 3. And 2 minus a minus becomes a plus. So 2 plus 1 is 3. And so I get negative 3 divided by 3 is negative 1. So that's our slope. And luckily, this piece of the line, we have the y-intercept. The y-intercept is the point 0, 1. So then that tells me that b is 1. So I can go in my y equals mx plus b, y equals m, so negative 1, x plus b. Just from the graph, I can tell that b is 1. If I didn't have the graph, then I have to go through either y equals mx plus b or y minus y1 equals mx minus x1, the point slope formula, to find the equation of the line. So now that I have the equation of that middle part, then I can go back to my question mark and get rid of the question mark and say that is the line when y equals negative x plus 1. And this happens when x is between negative 1 and 2. And remember, we wrote our interval here, so not including negative 1, but yes, including 2. So I'm going to put the equals there. And so that will be the function. So our piecewise function, and remember, it has to be a function, so it has to pass the vertical line test. So anytime I want to check if something I've written is a function or something I graphed, if I graphed a piecewise function, to make sure that it is a function, draw yourself little vertical lines, make sure it passes the vertical line test. And so that's why notice that one is solid and one is open, because otherwise it wouldn't pass the vertical line test because it would touch at 2 points. Okay, you could have also, you didn't necessarily have to do the slope algebraically like we did here. You could have just gone to the graph and say, looks like from this point, right, it goes up 1 and to the left 1, up 1 and to the left 1, so the slope is negative 1. Or you can start at the y-intercept and go down 1 to the right 1, down 1 to the right 1, and see, oh, the slope is negative 1. So you didn't have to do it algebraically. But this gives us the function for our piecewise graph. Okay. Another thing that we can talk about is whether the function is increasing or decreasing. And that refers to the y values, right? When it asks if a function is increasing and decreasing, the function meaning the f values. So that means the y values. Remember, f of x is a fancy name for y. So we want to see, are the y values increasing or the y values decreasing? So looking at this one, and now that I have all this chicken scratch in here, it might be hard to see, but notice that from our interval negative infinity to negative 1 is neither increasing nor decreasing, it's staying constant. What happens on the interval from negative 1 to 2? The function, what are the y values doing? Are they going up or are they going down? They're going down, right? So we would say that the function is decreasing because the y values are getting smaller. As you read it from left to right, the y values are getting smaller, and then here again is constant, so it's neither increasing nor decreasing. And so that's something that helps us for functions. To find information about a function, we may want to know when is it increasing or decreasing. So let's look at another example. So this one, find the intervals where the function is increasing and decreasing. And again, so in this case, find the intervals where the function is increasing and decreasing. So another way to interpret this is essentially saying find the x values for which the y values are getting larger or smaller. Getting larger and getting smaller. So that's really when it says find the intervals are going to be on the x-axis where the function is increasing and decreasing. This refers to y values. So one of the ways that we can kind of pinpoint is, well, where is it neither? Where is it not increasing or decreasing? And those are the peaks and valleys, right? So if you look at here, this is right at the kind of like, if you were to consider this looking like a parabola, at the vertex, this is neither increasing or decreasing. Same thing here. This is neither increasing nor decreasing. So at every, these are called peaks and valleys. The peaks is the mountain looking ones and valleys are the bowl looking ones. So that's where it's neither increasing nor decreasing. So those are sort of like our points of reference. And let's look at our scale again. So again, each square is 1, so then that's going to be 2, 3, 4, and so on. And then -1, -2, -3, and so on. And so these go on forever. So this goes down to negative infinity on the y, this goes up to negative infinity on the, or to positive infinity on the y, and same on the x. It just keeps going forever. So at -2 is where we have this is a valley, so it's neither increasing nor decreasing. So before that, we want to look at what are the y values doing? And we always look at a function from left to right. And what are the y values doing? Are they getting larger or smaller? They are getting smaller, right? Looking at our graph, let's see, 1, 2, 3. This is 4. So then they're getting smaller. So this is decreasing. So we can say that our function, let's call it f of x. We can say f of x is decreasing on the interval minus infinity, assuming this goes on forever, right? So if it goes forever on the y, then it must go on forever on the x. So minus infinity to, where does that value occur? At -2. And these are always parentheses because at a peak or valley is neither increasing or decreasing. It's just kind of like where it stops. Imagine if you throw a ball up in the air just vertically up, it's going to start, the ball is going to increase, increase, increase. And then at some point, like if you're looking at the like nanoseconds, it stops and then it starts to come back down. So the peak and the valleys are that point where it just switches from increasing to decreasing or vice versa. We're going to use the union to indicate the next interval. So that interval, or it's also decreasing from 0 to 1. Notice that the y values there get smaller. So from 0 to 1. And then where else does it decrease? And you can see here, the y values are getting smaller. So this is decreasing on, that's a peak. So that's at 3 to infinity. So the peaks, so that's a peak. They are also called local, this is a local maximum. And so this is a local maximum as well. Local meaning you're essentially kind of like zooming in on that interval. And so that's why it's a local instead of absolute or universal maximum. The universal maximum would be the highest point on the graph. But these go on forever to infinity, so it doesn't have a highest point. It doesn't have a lowest point either, so it doesn't have a universal minimum. So we look at the peaks and valleys for localized max or min. So the peaks are local maximums and the valleys, the little bowls, are local minimum. And so you can tell a local minimum because you go from decreasing to increasing. And you can tell local max because you go from increasing to decreasing. So like if you think about throwing a ball vertically up or in the air again, as it goes up, it's increasing. The altitude of the ball is increasing, right? It's getting larger, goes up, 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 and then in that nanosecond it stops. That will be the peak. That will be your local maximum, and then it starts to come back down. So the height of the ball, the altitude starts to decrease. And so that will be the intervals where the function is decreasing and it's increasing on the places where it's not decreasing. So it's increasing as it moves up. The y values move up, the function values. So we have two intervals where it increases. So this will increase from the valley, so -2 to 0, or from 1 to 3. And so that will be how our function increases and decreases. Now, if you are asked to identify your local max and local min, so we will say the function has local maximums at, and there are two. One is at 0, 0. So a local maximum is where it changes from increasing to decreasing, or you can think of it as a peak. And the other one is at 3. And what's the y value there? Looks like 1. Yeah, at 3, 1. Now, one thing to notice is that these are coordinate values. These are given as the location of the local max, right? So this is an x value. So the maximum occurs at 0, and the local maximum, the y value is 0. This local maximum occurs at x equals 3, and the y value is 1. Whereas these are x values, describing where the function is decreasing for what x values the function is decreasing. So there's a difference. I know they both have parentheses, and so sometimes that creates confusion. This is an interval of x values. This is the location of a local maximum or a local minimum. So this has a local minimum at, and there are two, the values. So at -2 and following our scale of 1 square is a single unit, so that will be -1, -2. So at -2 and -2, so again, so that means that we have a local minimum when x is -2, and the local minimum is -2 as well. And the other local minimum is at 1, -1. So it occurs when x is 1, and the value of the minimum is y equals -1. So that's how you interpret these versus an interval. These are x values for the function, but the y values are going down. And this is the range of x values where the y values are going up. So I hope that helps with section 2.3. And section 2.2 is more of these kind of stuff, the piecewise functions. Email me if you have any questions.